Today, we're going to talk about lessons 7, 3, and 4, multiplication and division properties of exponents. So we are going to actually explain and use the laws of exponents, or properties of exponents. So first of all, we're going to talk about the product of powers property, which you can see here in words. It says the product of two powers with the same base equals that base raised to the sum of the exponents. They give you an example here. 6 raised to the power of 7 times 6 to the power of 4 equals 6 to the 7 plus 4 power, or 11. When it's written with variables, a to the m plus a to the n equals a to the m plus n. So you worked with these yesterday, and when you were working with them, some of you were probably coming up with these rules, and with this power rule, the product rule here, pretty simply, is that you said, okay, well I have 8 to the 5th times 8 cubed. So I've got 5 eighths here, 3 eighths here. So we say, well, that's 8 to the 5 plus 3, or 8 to the 8th power, right? So I know some of you are getting it, because if I write it out, I got 5 eighths multiplied by 3 eighths, and I've got 8 eighths there. So this rule works with all of them yesterday, where we were writing them all out because we wanted to see them, right? That all we have to do is, if we're multiplying with the same base, we add the exponents. Here we have y to the 9th times y to the 1st power. So it's going to be y to the 9 plus 1, y to the 10th power. So we multiply with the same base, we add the exponents, right? And here we have a to the 4th, a to the 3rd, a to the 10th, right? You probably already have this one answered. 4 plus 3 is 7, and 7 plus 10 is 17. So that would be a to the 17th power. Now the thing is about this other one here, 2x to the 4th times 3x to the 5th, whenever you have parentheses in situations like this, and we have constants like the 2 and the 3, or leading coefficients, the thing you want to do first is to rewrite it. So this is going to be 2 times 3, and then x to the 4th times x to the 5th. That will make it much easier for you, and that'll help to remind you that you've got to multiply that 2 and that 3 together to get your final answer. So this is going to be 6, and then we have the same base here with x. So 4 plus 5 is 9. So 6x to the 9th power. All right, so that is the product rule of exponents. When we multiply with the same base, we add the exponents together. Right? The power property. Right? So there's actually two powers. There's power of a power, and there's power of a product. And these we actually worked with yesterday also. And so let's, I'm not going to talk much about these. I just want you to look at, the rules are there, but I think if we go right to it, that you'll understand it because you were working with them yesterday. So we said that this one here, the 7 to the 4th to the 3rd power, well, that would be 7 to the 4th times 7 to the 4th times 7 to the 4th. All right, well, that takes us now back to the product property, which says, well, if I'm multiplying with the same base, I add the exponents. Well, how many 4s am I adding together? Well, I'm going to add 3 4s together. Well, that just means I have 7 to the 4 times 3 power, which is 7 to the 12th power. So if we have an exponent on the outside of the parentheses, all right, then we're going to multiply it by the exponent on the inside of the parentheses, right, which is the example up here. This is the power of a power property. Okay. So here we have x to the 5th to the 2nd power. Well, that just means x to the 5 times 2, or x to the 10th power. Okay. So if we are raising to a power, then we're going to multiply those exponents, right? Now this one here, the quantity negative 10x to the 6th, that squared, is a little bit harder just because we have that constant involved. So what I'm going to do is I'm going to rewrite this then, because this means negative 10 to the 2nd power, and x to the 6th to the 2nd power. So that's one of the ways we can think about it. Well, what's negative 10 squared? That's 100. And 6 times 2 is 12, so x to the 12th. But let's look at it like we were looking at it yesterday also, just to verify that for you. That, remember yesterday we said, okay, well we have two of these things, so that would be negative 10 x to the 6th times negative 10 x to the 6th. Right? And so here we know that this is negative 10 times negative 10 x to the 6th, x to the 6th. So just to verify that for you, that if, in this case, that's kind of a little bit tougher. So maybe writing it back out like this will actually help you to get those. All right? Same thing here. We have 1/3 xy cubed. So what we have to do is we have to basically distribute the 2. So we've got 1/3 to the 2nd power, x to the 2nd power, and y cubed to the 2nd power. So you have to remember that that exponent on the outside then is going to each one on the inside. So we have 1/3 squared is 1/9, and then x squared, and y cubed squared is y to the 6th power. So we have this exponent on the outside of the parentheses. I'm going to multiply it by any exponents on the inside. So that's the power of a power rule. So we call that just the power rule. Okay. Then we have what's called the quotient rule. Okay. The quotient rule is involved division. Right? And so with our division, now if we work with this one here first, we got 2 to the 5th over 2 cubed. Okay. So yesterday we would write this, okay, 2 times 2 times 2 5 times. And 2 times 2 times 2 3 times. Well, let's think about this for a second. Since I have those 2's in the numerator and those 2's in the denominator, I can cancel them. I'm canceling 1, 2, 3 2's. So really what I'm doing is I'm subtracting 3 2's from my problem, and I'm left with just 2 of them. So this is just 2 squared because 2 to the 5 minus 3 is equal to 2. So if we take the exponents, then when we're dividing, we're going to subtract the exponents. All right, so it's very important excuse me, that you recognize the base, what the base is, so you have that correct. So here we have 2 to the 11th over 2 to the 6th power. So our base, so that we're just clear here, our base is 2. That's the thing that's being raised to the power. So we take the 2, and we're going to do 11 minus 6, or 2 to the 5th power. So we take the exponents when we're dividing, and we subtract them. Okay. Here our base is negative 4. So we have to make sure that whenever the base is a negative, you have to leave it in parentheses. And if we do 7 minus 4, we get 4 to the 3rd power. All right, so I want you to do these next two. So go ahead and pause the video, and I want you to do this one here. All right, and then come down and do this one down here too, before you turn the video back on, to see if you can do them without my assistance, first of all. Okay, so if you've done them, you should have gotten this was x squared. And this other one down here, because we have the 3 and the 12, so we would pull it apart. We got 3 over 12 times y to the 11th over y to the 5th. So I pulled the numbers apart, and we can write this two ways. We have 3/12 is 1/4, and 11 minus 5 is 6, so 1/4 y to the 6th power. Right? Or if you wanted to, you could write that as y to the 6th over 4. Either one would be acceptable in this situation. and this last one here. Now this one's a little bit harder just because we have all of those different variables. And if it helps you, pull it apart. 6 over 2 times x to the 9th over x. Y to the 4th, y squared. Z to the 5th over z to the 4th. Okay. If it helps you, go ahead and write them separately so you can see them a little bit easier. And we end up with 6 divided by 2 is 3. 9 minus 1 is x to the 8th. 4 minus 2 gives me y squared. And z to the 5th, so 5 minus 4 gives me z to the first power. So I just need to put z there. Okay. All right. So there's the quotient rule then. If we are dividing with the same base, then we subtract the exponents. All right. Subtract the exponents. All right, so here's a couple others just for you to go ahead and do. Take a look at them and see if you can do them on your own. So pause the video, do them just to check to make sure you are doing some of them correctly. So go ahead and do that. Pause it for a moment and check them. All right, so the answers for these are, we have 2 cubed, or 2/3 cubed, so that means we have 2 to the 3rd over 3 to the 3rd. Right? The 3, the exponent applies to both. So this is going to be 2 cubed is 8, and 3 cubed is 27, 8 over 27. Okay? For the next one, we have x cubed over y cubed. So that 3, that exponent, with our power rule, if we have a fraction, it applies to everything in that fraction. Okay? If we have a fraction, the power applies to everything. So here we have 2 cubed, x cubed, and then we have to multiply that 3 times 2 down here for the y squared, so we get y to the 6th power. So we get 8 x cubed over y to the 6th power. So when we apply the power rule here. Okay. All right, now, sometimes they get a little bit harder, and so we're going to look at this thing here called gemdas. Now, we've worked with other stuff before, like these, but instead of gemdas, we worked with PEMDAs, right? PEMDAs, right? We said parentheses, exponents, multiply, divide, add, and subtract, right? Just our order of operations. Well, order of operations, we could use PEMDAs or GEMDAs. In this case, this website I borrowed this from uses GEMDAs, and it's just, instead of parentheses, they just say, okay, well, that's grouping symbols. Right? So any grouping symbols, or we have then we have our exponents, and then we're going to multiply and divide and add and subtract. So we have our grouping symbols here. Well, let's think about how those grouping symbols really apply for us then when we're working with exponents, because it comes in handy with them too. All right, so let's see how they applied. So if we had 2 to the 3rd to the 4th power. So here we have grouping, all right? And so we are working with exponents here. And so when we're working with exponents, we do what? We multiply. So you can see here is, in the GEMDAs, if we have exponents, then we multiply, because this is 2 to the 3 times 4, or the 12th power. Okay. Or another one is that, okay, so if we have 4 to the 3rd times 4 to the 5th. Okay. Well, here we are multiplying 4 times 4, okay, 4 to the 3rd times 4 to the 5th. We're multiplying, so that means that we are going to add. So with the GEMDAs, if I'm multiplying, same base, what do? I add the exponents. And then the third one is, so what if we're dividing? So this was what, 4 to the 8th. Right? So if we're dividing, say we've got 4 to the 9th over 4 to the 5th. Well, we know that's 4 to the 4th because we're going to subtract. So, hey, look at here. If I'm dividing with exponents, we subtract. So you can use the GEMDAs to determine how you are going to simplify these. All right, so let's take a look at a couple others. All right, using the GEMDAs. All right, so here we have multiplication, 5y cubed times 6y to the 7th. So that means we are multiplying, so we are going to add the exponents. So we have 5 times 6 is 30, and y to the 3rd times y to the 7th. We add those exponents, we get y to the 10th. So it might help you when you start doing some of these is write down GEMDAs and use that to apply. Right? So here we are again. Here we have an exponent on the outside of the parentheses. So if we have an exponent, that means we're going to multiply it by the exponents on the inside. So we get 4 to the 4th because the exponent of 4 here was 1. Times x to the 4 times 5 is 20, and y to the 3 times 4 is 12. So 4 to the 4th, which is actually 256, x to the 20th, y to the 12th power. Okay, so you go ahead and see if you can do this last one then, where we have the division problem or a quotient, and see if you can do that one. All right, so you probably worked on that then. Stop the video, worked on it. So here we have a quotient, so we're dividing. So what are we going to do? We're going to subtract the exponents. Now in this case, 5 doesn't go in the 7 in our numbers there, so we're just going to leave our fraction bar, leave the 5 in the numerator, 7 in the denominator. 88 over a to the 5th gives me a to the 3rd, that's in the numerator. And b to the 5th over the b to the 3rd gives me b squared. Okay. So, GEMDAs helps us with these. All right, so we have one last one here. So why don't you go ahead and try to do this one on your own, all right, first, and then I'm going to go ahead and do it too. All right, so hopefully you've tried this. All right, so we're going to, first of all, we have to use our grouping. So we're doing this GEMDAs again, all right? We're grouping. So the first thing we have to do is we have our exponent and we're going to multiply. So I'm going to write that in red. So we have 2 to the 3rd power, a to the 9th power, b to the 12th power, because we're going to distribute that 3, we're multiplying it by each of those exponents. All right, there's our EM of this. So what do I still have? I still have times 4ab to the 5th, and I still have 64a to the 5th b cubed. All right, so our next step then, we'll write that in blue. Now we have multiplication in the numerators. We're working the numerators, so we have multiplication, so we're going to add the exponents. So let's see, let's change that. 2 cubed is now 8. And we also have a times 4, so let's do that all at once. 8 times 4 is 32. And a to the 9th and a to the 1st would be a to the 10th. And b to the 12th and b to the 5th, b to the 17th. So we were multiplying, so we added the exponents. All right, and our last step here then, we are dividing, so we are going to subtract. Well, first of all, we have 32 over 64, so 32 goes in 64 twice, so I'm going to put that in the denominator. All right, now if you want to write it as 1/2, you can. All right. So then we take our exponents, and a to the 10th and a to the 5th, so 10 minus 5 is 5, so we have a to the 5th in the numerator, and b to the 17th over b to the 3rd, 17 minus 3 is 14. So our final answer there, a to the 5th, b to the 14th over 2. So we're working with the properties of exponents. The product property, we multiply with the same base, we add the exponents. The power property, right? If we're raising to a power, then we're going to multiply the exponents. And the quotient property, if we're dividing with the same base, then we subtract the exponents.